We're now going to talk about the different types of chemical reactions, and there are a total of 6 different types of chemical reactions. The first type of chemical reaction I want to talk about are what we call combustion reactions. Combustion reactions are simply reactions of compounds that react with oxygen. So anytime you have a compound reacting with oxygen, it's going to be considered a combustion reaction. Whenever something reacts with oxygen, it burns, and so that's why we call it combustion. Now, a very common combustion type reaction is a reaction with hydrocarbons. And so an example of that would be methane, which is CH4 reacting with oxygen. So again, it's reacting with oxygen. We'll always produce 2 compounds, carbon dioxide and water. Whenever you have a combustion reaction reacting with a hydrocarbon and oxygen reacting together, it will always form carbon dioxide and water. So that's the case for all combustion reactions. The second type of reaction we want to talk about are what we call decomposition reaction. A decomposition reaction is exactly like it says. It's something that decomposes. So it will be one particular compound, so one thing decomposing into more than one thing. So a generic example would be some compound, let's say it's AB, decomposing into A plus B. And so this would be an example of a decomposition reaction. An example of this would be, for example, magnesium oxide decomposing into magnesium metal and oxygen gas. And so balancing would be this right here. And that would be a decomposition. We would have one thing breaking up into 2 or more than one thing. The third type of reaction is just the opposite of a decomposition reaction, and that is a combination or a synthesis reaction. So in a combination reaction, we have 2 things or more than one thing combining together to make one thing. So an example would be A plus B going to AB, or if we wanted to have a reaction, we could say carbon plus oxygen making carbon dioxide. This would be a combination or a synthesis reaction. So notice the decomposition and combination reactions, they're one and the same, just opposites of each other. The fourth type of reaction is a little bit more complicated. We're going to call this a single replacement reaction. In a single replacement reaction, we always have one element, and a lot of times it's a metal reacting with a compound. So an example would be, let's say we have aluminum reacting with HCl. And so here we have a metal reacting with a compound, and that will always produce another element and a compound. So in this case, we would have hydrogen, which is an element, reacting on aluminum chloride. So here we have one element and a compound going to another element and another compound. And so this would be a single replacement. Generically, what we're doing is we have A plus BC goes where we have A and B kind of flipping spots to make B plus AC. Now we could also have A plus BC making C plus BA would be another possibility. So these are all single replacement, where we have one thing and one element and a compound reacting together to make a separate element and a different compound. Now, the way we can predict whether or not a single replacement reaction happens is what we call an activity series. An activity series is something that is determined experimentally, and simply a series of experiments are done just to see if a reaction happens. And so what we do is we have this series of elements that just simply is the more reactive elements being at top or in the front, first on the list, and the least reactive being on the bottom or at the end of a list. So an example of an activity series would be potassium, sodium, lithium, calcium, magnesium, aluminum, zinc, iron, hydrogen, copper, and so forth. And so we can have lots of different elements. So whenever we have an element up here, it will always displace an element below it. So in this case, in the previous example, we had aluminum displacing hydrogen. So we see aluminum is here, hydrogen is here. So that means aluminum will displace hydrogen. So the example we had aluminum plus HCl going to H2 plus AlCl3. And so the aluminum will displace the hydrogen. Aluminum is more reactive than hydrogen. Aluminum is higher than hydrogen, and so aluminum will react and displace the hydrogen. It will basically kick out the hydrogen because it's more reactive. So another example, let's say we have magnesium with iron 2 nitrate. So magnesium is above iron, so that means that magnesium is more reactive than iron, and so magnesium will kick out iron to make it iron, and then the magnesium will react to be MgNO3, and we have to have 2 of that because of the charge of the magnesium. And so this would be a single replacement reaction. Now let's say we had, for example, copper. So we want to react with copper with magnesium chloride. So copper with magnesium chloride, copper is below magnesium, so copper isn't strong enough, isn't reactive enough to kick out magnesium. So in this case, there would not be any reaction that would happen. So for a single replacement reaction, the elements have to be above the element that is trying to kick out for it to actually react. Now, one thing that all these reactions have in common, the combustion reaction, combination, decomposition, single replacement reaction, all of these reactions are what we call reduction, oxidation, or oxidation reduction reaction. And what that means is that there is electron transfer that is happening. Whenever these reactions are occurring, there's electrons that are moving from one element to another element. And whenever electrons get transferred, then that means we have an oxidation and reduction process that's happening. Now, I would highly recommend that you look at my other video dealing with oxidation numbers for you to figure out how to determine oxidation numbers. And that helps you determine how the electrons are being transferred. So let's say, for example, we want to react magnesium with oxygen to make magnesium oxide. This would be a synthesis or combination reaction. And in this case, these magnesium would have an oxidation number of 0. Oxygen has an oxidation number of 0. In this case, oxygen has a -2, and the magnesium oxide, magnesium has an oxidation number of +2. So here, the magnesium is going from a 0 to a +2, and the oxygen is going from a 0 to a -2. So we see that there's a change in the oxidation number. Whenever we have a change in the oxidation number, which happens with combination reactions, decomposition reactions, single replacement reactions, and combustion reactions. If it's one of those 4, we are going to have a reduction oxidation reaction, and it's simplified as a redox reaction. And so whenever you have a change in oxidation number, you have a redox reaction. In this case, if we look at magnesium, we notice that magnesium goes from a 0 to a +1. We have an increase in oxidation number. Whenever you have an increase in oxidation number, that is what we call oxidation. And then we notice that oxygen goes from 0 to a -2. That went down in oxidation number. So whenever we have a decrease in oxidation number, that is what we call reduction. Hopefully that name kind of makes some sense. Reduction means a decrease or reducing of oxidation. And so, like I said, oxidation reduction or redox reactions always happen with combination reactions, decomposition reactions, combustion reactions, and single replacement reactions. Now we have a 6th type of reaction, what we call a double displacement or double replacement reaction. And a generic way of writing this, so this would be number 6, double replacement. A generic way of doing this would be AB plus CD. So this is when we have 2 compounds, AB and CD, reacting together to make 2 new compounds. And so 2 new compounds would be AD and CB. So whenever we have two compounds combining together to make two new compounds, this is what we would call a double replacement. Now these are not redox reactions. In fact, we would call these non-redox reactions because there's not going to be a change in the oxidation number that happens. An example of this would be, there are actually three types of double replacement reactions that can happen. The first type is a precipitation reaction. A precipitation reaction is any reaction where a precipitate or a solid is formed. So an example of this would be silver nitrate reacting with hydrochloric acid to make silver chloride and nitric acid. Now here, notice what happened. Just like up here, we have A and C flipping spots with the B and the D. Here we have the silver is with the nitrate. Now silver is with the chloride. So the silver and the chloride, basically the silver and the hydrogen switched. So the silver flipped with the hydrogen to be silver chloride. The hydrogen came over here with the NO3 to be nitric acid. This is what we would call a precipitation reaction because silver chloride does not dissolve in water. Silver chloride is insoluble in water, so a solid would form out. Now there are solubility rules that help us determine whether or not a solid or a precipitate will form whenever we have a double replacement reaction. Generically or generally, we can say that if there's a nitrate, all nitrates dissolve in water. So if you have a substance that has a nitrate with it, it will always dissolve in water. So silver nitrate dissolves in water. So we can write that as an AQ. Also, all the halogens, all the halides will dissolve in water as well. There are some exceptions to that. So exceptions are whenever a halide, so remember the halides are iodine, bromine, chlorine, and fluorine. So whenever those halides bond with silver, they will be insoluble in water. And so that's what happened here. Silver chloride does not dissolve in water because silver chloride, while generally a chloride is soluble in water, it does dissolve in water. When it bonds with silver, it no longer dissolves in water, it becomes a precipitate, and therefore we have to write a solid there. Another example would be the lead 2+ ion. So if, for example, we form PbCl2, this would also form a solid in water as well. And another example, besides silver and lead, is the mercury ion as well. Although you would very rarely see the Hg2, but I do need to mention that. The mercury ion does not dissolve in water as well. So the halides will dissolve in water as long as they're not bonded with silver, mercury, and lead, basically. So basically, if there's a nitrate, it's going to dissolve in water. If it's a halide, it will dissolve in water unless it's bonded with silver, mercury, or lead. And then also any ammonium ion. Ammonium, the NH4+ ion. So if NH4+ is bonded with something, let's say ammonium chloride, that would also dissolve in water as well. So the precipitation reaction is a type of double replacement reaction. Another type of double replacement reaction is an acid-base reaction. Acid-base reaction is exactly what it says. It's whenever we have an acid and a base reacting together. And so whenever an acid-base reacts together, acid plus a base will always form a salt and water. Now, salt in chemistry means any ionic compound, so any metal with a nonmetal, or I should say a cation with a anion. So an example of an acid would be hydrochloric acid with sodium hydroxide. So sodium hydroxide would be a base. This is a double replacement, so the hydrogen and the sodium are going to flip spots. And so the sodium is going to be with the sodium chloride, or with the chloride to make sodium chloride, and the hydrogen is going to go with the OH to make HOH, or simply H2O, which is water. So here we have salt and water. And that would be the case for any time we have an acid with a base. And you know you have an acid whenever you have a hydrogen with a polyatomic anion. And then you also have a base whenever you have an OH, the hydroxide ion, with a metal cation or a polyatomic cation. Now the third type of double replacement reaction is a gas forming reaction. And so gas forming reactions are when this happens, when you have two compounds coming together and a gas actually forms. And so those are the 6 types of reactions that we have. We have combustion reactions, which is any reaction bonded or reacting with oxygen, the most common being a hydrocarbon. And whenever that happens, we will always have the products of carbon dioxide and water. We have synthesis or combination reactions, so that's when 2 things combine together to make one thing. Decomposition reaction, where we have one thing breaking up into 2 or more things. We have single replacement reactions, which is when we have a element reacting with a compound to make a new element and a new compound, and that is governed by the activity series. And then we also have the redox reactions, which are any reaction that where there is electron transfer that's happening. And then finally, the last type of reaction, which is a double replacement. And of the double replacement reactions, we have basically 2 compounds combining together to make 2 different compounds. Now, there are 3 different types of double replacement reactions. We have a precipitation reaction, which is determined by a precipitate forming, and a precipitate forms whenever we look at the solubility rules to see if a solid forms in an aqueous environment. And then we also have an acid-base reaction, and then a gas forming reaction. And so those are all the different types of chemical reactions, and all chemical reactions can be classified or grouped in one of those categories.